Today is all about the future shock. We are going to talk through the history, the technical details, and take a closer look at what makes this piece of technology an inspiring innovation and how it functions as a performance benefit to the rider. I'm totally thrilled today to be accompanied by John Cordoba, product manager at Specialized. He's been involved with the Future Shock for a very long time, and I can't wait to pick his brain. We also have Tyler, an engineer with the team, and here and there we'll ask him to kind of give some more detailed explanations as we get into the nitty-gritty here. Totally thrilled. Let's jump in. Now, the idea for the Future Shock was born from the need to tame the roughest roads that cyclists encounter. One of the most notorious races in the world, the Paris-Roubaix, this monument of bicycle racing, is 260 kilometers long and features sections of Roman-era cobblestone roads interspersed with sections of smooth asphalt. The bikes must be compliant enough to smooth out the rough sections, but have good enough power transfer to not slow the riders down over the smooth sections. Obviously, that's quite a task at hand. But fortunately, we're really no strangers to that. We've tackled the topic of comfort. We've handled compliance. We've done our best to smooth it out, whatever you want to call it. We've tried it in a number of different ways. Many of you probably remember this. This is Zerts. This was one solution that we had, and honestly, it was a great solution at the time. It was visible. It did dampen vibration, but guess what? Wheel and tire technology really improved, and soon we found that that riders were able to push the boundaries even further. In time, we knew we needed to take it a step further to figure out how to tackle this terrain. We looked to motorsports. In motorsports, suspension defines the vehicle's speed and performance. They've known this for years. It smooths out the terrain and improves traction by maintaining the tire's contact patch with the ground. Mountain bikers know these benefits also quite well. It's no secret, the smoother the ride is, the faster the rider is. With suspension on a bicycle, of course, there can be loss of pedaling power. For a performance road cyclist, that could totally be a deal breaker. These riders will go to extraordinary lengths to save a couple of seconds off their time. And if their efforts are being canceled out by the bike they are riding, well, obviously they wouldn't ride that bike. Not a chance. So, all that being said, clearly suspension is for performance. But the big question remains, how do you go about adding suspension to a performance road bike? Well, we started back in 2012 researching road suspension, giving the engineering team an opportunity to go wild. Naturally, some very interesting prototypes came to life. Then, more research. It became evident that suspending the rider from the frame was the best way to gain added performance of suspension without a loss of pedaling power. We learned a lot in that process, and mostly we learned the idea of splay versus axial movement. And I'm going to look to John to sort of talk a little bit more about what that means. Now we show some of our early prototypes. I think this is a fork made out of maybe 2 CGR seat posts. This may be a good example of what might happen when you give the engineering team maybe too long of a leash. But fortunately, we've got guys like John on the product side that really kind of help keep things grounded. John, can you tell us a little bit more about what we learned from this prototype that we're looking at?
Yeah, so we knew that from the studies that we have done with McLaren, that we wanted to get some sort of axial movement out of the front wheel. We knew that we wanted to make sure that the wheel went up and over the bump instead of going back and forth. And we were trying to figure out how to tackle that. And the engineering team did a great job here at trying to figure that out. We, like Jared said, we maybe went into a deep rabbit hole until we finally got these samples to ride. And we realized, like, wait a second, like, this is not what we're expecting. For one, these prototypes did get the wheel to move up and down, but we didn't get that much travel. We got about 8 millimeters of travel. It was extremely hard to manufacture, and there wasn't enough of the travel that we were expecting. So we went back to the drawing board.
Yeah, it was so 8 millimeters of travel. Yeah, that certainly doesn't sound like very much. But we have landed on a number. Ultimately, we did land on a number, an amount of travel for this. Could you tell me, were there any benchmarks that were sort of set in place early that we wanted for what we wanted to achieve of travel? And if so, how did we, what did those come from?
Yeah, we just started measuring kind of like, went out and rode some of the roads around Morgan Hill. As many of you know, like the roads are in really bad shape, and started measuring some of those different roads, the cracks in the roads. Then we went obviously to the cobblestones of Paris-Roubaix, and we realized that 20 mils was probably the biggest impact or object that we were going to see on a road style setup. And so that's kind of where we landed on the 20 millimeters of travel.
So you're saying that going to Roubaix and really tackling this sort of very focused on creating the ultimate weapon for this, we saw 20 millimeters was about the max, or the average sized impact of the cobbles that we were going to see. And that informed, at least partially, coming into that 20 millimeter number.
Correct, yeah.
I think that's an incredible story. Now, we're coming up, we're going to talk a little bit more. We'll show, sort of an older train of thought, or what had been done before looking into axial movement that we settled on. Before, you were talking about, the fore and aft movement of that, which we refer to as splay. Now, this is sort of showing the way that the axle is going to move as a result of splay. Now, what do you have here?
Yeah, so every bike manufacturer, including us, we wanted to get some sort of comfort or movement out of that front wheel. Since the beginning of time, we've been wanting to find ways of creating some sort of comfort, right? Especially on road bikes when tire pressures were 120 psi, and wheels and tires were not that great. So we figured that by allowing the fork to move backwards and forward, it did give us some comfort. But what we found out is that it actually slowed us down. Anytime that the fork compressed backwards and then rebounded back forwards, it actually slowed us down, because then the bike is moving backwards as the fork is moving forward. That was kind of the beginning of us understanding that we needed to have an axial movement instead of a splay.
Absolutely. And were there any particular tests or outside influences that sort of guided us into these learnings?
Yeah, that was a lot of the work that we did early on with McLaren back, 10 years ago when we were working with them. Luckily, our partnership with them allowed us to tap into some of their simulations facilities that they have. And that's probably like one of the biggest things that we got from them is using some of the simulation machines. And we were able to put courses in these simulations, and then in those courses change variables like having a completely rigid fork with no movement, or having a fork with display movement, or then having an axial movement like how much more efficient was this? So when we started the project, we really started to figure out how to get compliance. But then it quickly turned into how do we get the bike to be more efficient?
Sure.
And that's kind of what drove us into the Future Shock, is like, how do we become more efficient?
Right. Yeah. I mean, as you know, like you said, exploring the avenues of splay, the zerts that we talked about, you know, that was some form of compliance, but not exactly the most efficient. So really, really forward thinking stuff. We also have, you know, maybe some geometry changes that kind of take place when you start really exploring the limits of using splay as a mechanism for gaining comfort and compliance. You can have some alterations in wheelbase and sort of effective head tube angles going on all the time as you're going over obstacles, which certainly doesn't seem ideal.
Yeah, I don't know if many of you remember, I guess the last SL4 Roubaix that we did. That's kind of when I started working on the Roubaix family. And personally, I was not a huge fan of that geometry, in particular out of the saddle. It felt like, I don't know if a lot of you felt this, but it felt like it swayed back and forth like very easily. As soon as you got out of the saddle, like the bike wanted to tip over, and a lot of it had to do because the number one priority was to get some compliance out of the fork. So the geometry would also have a really long fork offset.
Okay. And so what would that long fork offset do to the trail figures, and how did that exactly correlate to that feeling of the bike kind of being tippy or floppy?
Yeah, well, we had kind of a steep head tube angle and a large fork offset, which is complete opposite of kind of what we see on today's modern gravel bikes. And so what that did is just kind of it gave us the we called it the wandering wheel, and it was kind of like the wheel was in front of you, like not having a real place to go to.
Sure. I'm familiar with that sensation, but of course, more from the mountain bike side of things, as that's where I'm more heavily rooted. But I get that. And so, but those were the necessary confinements I imagine we were dealing with in trying to maximize what we could for comforts through splay.
Correct.
Awesome. Well, so moving forward, we kind of do this research, work with McLaren, we learn about axial movement, but of course, not all forms of axial movement are created equal, right? So, you know, we do have axial compliance below the head tube. Now, this illustration is, you know, showing a road bike. Well, we're obviously not too used to seeing that, but in practical senses, axial compliance below head tube, that's a suspension fork for a mountain bike, right? So, you know, just like a traditional mountain bike fork, suspensions, it's moving the wheel in relation to the frame. This definitely solves for splay, and it is going in the right direction for efficiency, I imagine, but there are restrictions there for a performance road or mixed surface application. It's inherently less efficient. Right? It doesn't pass the efficiency test that for power transfer that we would need for this performance road cyclist. And it doesn't really solve for changing geometry either, right? We still would be falling victim to a diving head tube, a change in wheelbase and change in head angle and all things like that, which are obviously less than ideal. So with that being said, and you guys did all the learnings with this, we landed on suspending the rider by sort of flipping that upside down, so to speak. We moved the suspension from below the frame to above. It sounds really simple. I'm sure it came with a whole host of challenges that met you every step along the way. But with this, well, what are our big benefits, right? There's no measurable loss in power transfer, no change in wheelbase, no change in head tube angle, but we still get the comfort and the control where it counts. I recently heard an interesting thing about sort of being able to do some form of efficiency test with this by simply putting the bike in a trainer, right? And taking your hands off the handlebars and pedaling really hard. You have axial compliance happening below the head tube. Hands off the handlebars, it could still move and be able to kind of sap that energy. Moving our axial compliance to the top of the head tube, as the Future Shock is. Hands off the handlebars, power down in that trainer, and the wheel contacting the ground is completely rigid to the frame and to where your legs are pushing down. So you can really get an easy visual on how efficient this system is. So instead of below, we just go up. What sort of challenges sort of met your team along the way in bringing this idea to a reality?
Well, I guess at the very beginning of Future Shock, we didn't know what the form factor of an actual Future Shock was going to be. So the biggest challenge, and maybe it gets overlooked now because of where we're at, is that when we were developing that first Roubaix with Future Shock, we had some deadlines to make the frame and fork go into production. But yet we didn't know what the form factor of the Future Shock was going to be. So we had teams like Tyler's team working on the Future Shock, and then we had Luke's team working on the frame separately, and they had to stay in constant communication trying to figure out how these two form factors match together. So that was I would say the biggest obstacle of how to do it. And the second one is, how do we package all this in a lightweight, small unit into the frame, right? We see what are called gravel forks out in the market, or lightweight suspension forks out there, and they're still well over 1,000 grams, while a carbon fork and the Future Shock are just around 700 grams for both of them. So it's extremely lightweight for the application. And yet, so we were inventing this along the way.
Yeah, I mean, absolutely. And I mean, right, even down to the smallest little details of, maintaining adjustable stack height to meet a wide range of riders. What do you do with your stem interface? How do you achieve that adjustable stack height? How do you adjust a headset now? By occupying this valuable real estate that since the dawn of time, we've had really two methods of fixing a stem to a fork and being able to adjust this, the old threaded quills, and then, 20, 30 years ago, whatever it was, we go to a threadless headset, and I imagine that a whole number of those little small things coming along the way must have been a real handful. And like you said, trying to maintain that small light package. But hats off. Sounds like, we definitely achieved, and we did it. We've got a heck of a product here. And as a matter of fact, it was kind of seemingly so widely well received that despite it really being born from the needs of attacking the Paris-Roubaix and creating the most efficient means possible to do that in a performance road application, now we certainly find Future Shock taking its home on the front of a much wider range of product than just the Roubaix. That's smoother is faster. It turns out that has applications that reach way beyond. Now we find this on the Cirrus X, the Turbo Vado SL, the Diverge, the Turbo Creo SL, as well as the Roubaix. And the Future Shock, right now it's available in 2 versions. We have the 1.5. It's a spring-based system. How does that work? The 1.5, that's got a progressive mainspring in it. But what does progressive mean? That means it's soft and supple off the top to maintain the best high frequency compliance to the rider, but it gets stiffer as you go into the travel, and that really helps prevent that harsh bottom out. It ramps up, might be another term that you'll hear used. With that, we also have top and bottom out bumpers, keeps that Future Shock 1.5 feeling super smooth, gives the rider confidence at speeds. They're feeling great. And this one, right, John, can also still be adjusted using different spring weights, depending on rider's stature?
Correct. Well, and so I guess the different springs are really encouraged to be used depending on the terrain of the rider. So we developed the progressive spring to be used on its own without a booster springs, what we call the springs that go on top. But if the rider is doing some terrain that's a little bit more aggressive, example, cobbles, and they're going at higher speeds into those cobbles, we want to make sure that we have a better control of the Future Shock, and we do this by the different springs. And I encourage riders to check out which spring works the best. But if a rider is going to be riding 90% pavement, even 70% pavement, I would recommend to ride it without the booster spring, which the bikes.
Okay. And that's great feedback. That's awesome advice. Now, could you tell me a little bit more about how this product came to be across so many platforms? You know, again, kind of coming from, you know, really looking at building out the Roubaix to be the ultimate package, and now we see it across other things. What was this like for you and your team within Specialized as other departments and people started to see what it was that you guys were working on?
Well, I think it just goes back down that we're all riders that specialize, right? So, you know, it wasn't long after we had the first prototypes that Chad came about, and like Chad, who manages the fitness bikes, and he's like, "Hey, can I check out one of those Roubaix?" And he rode it over the weekend and came back and was like, "You know, that would be really good on a Cirrus or a, you know, back then we weren't thinking of the Vado SL yet, but he really imagined having this on some of his fitness family bikes." And luckily on Diverge, at the same time I was working on Roubaix, I was also working on Diverge. And it took a few of us to take out the Roubaix. And what we ended up having is that we would take the bikes on terrain that was definitely not pavement. So we kept on pushing the limits of the Roubaix more and more each time we took it out. It's like, oh, you know, LOs would come back and like, did you check out this gravel road? And we started exploring, and we started to think like, what if we put this on a Diverge that has a bigger tire and a lower bottom bracket? Like, would that help us go faster and have more fun on a gravel bike? And so that's how it came about to put it on the Diverge.
Okay. Always pushing, you know, us tinkery little riders that we are. I know we're always tinkering. I certainly always am. You could probably see part of my workbench back here. I've always got stuff everywhere. You know, I got a question here for you from someone else, from Rob. Does current Cirrus, not Cirrus X, use Future Shock 1.5 or 1.0?
Everything starting 2000 MY20, so everything that got shipped by summer of 2019 has Future Shock 1.5.
Got it.
So anything with a smooth boot is a 1.5. Essentially, is how you can tell apart.
Perfect. And another one, and this is a great question, is FutureShock 2.0 backwards compatible with older Roubaix and Diverge? Retailers have been hearing conflicting info on this.
Yeah, so yes, it's compatible. Like anybody can go ahead, it's the same diameter. You can put it onto an older Roubaix. However, we didn't do any testing on those older Roubaix forks, right? Like at Specialized, we're always forward thinking. We can't stop and then start testing older fork to see if new product is compatible with old product. So because we didn't do any of the testing, we can't liably say that yes, it is compatible. Also, on sizes 54 and below Roubaix, the actual FutureShock, because we added a damper, which we'll talk about later, got taller. So it doesn't actually go all the way deep down into the steer tube of a 54 or below Roubaix from previous generation.
Okay.
So if somebody wants to do that, one, the fork hasn't been tested, and two, the stack that they need may not be achievable through that.
Right. If they're a rider that wants as aggressive a position as possible, they're running the zero stack top with no spacers, they're not going to get there.
Correct.
I understood. Now you mentioned to the damper, and that's a great segue to talking about 2.0. This is the latest and greatest from the team for FutureShock. And as far as this goes, it's no secret we work very closely with our professional teams, right? And as I understand, they were persistent. We want a lockout. But why did they want a lockout? I imagine it's not simply because they're persnickety European roadies. There must be a good reason. And as I understand, we dug deeper into that, and it did become clear that what they wanted really was, they wanted a lockout. They also wanted maybe a greater level of control over their ride experience, right? And hey, if they want it, maybe everybody should have it. So we did look into doing that, and that's what we've achieved with the FutureShock 2.0. This features hydraulic damping, hydraulic compression, and rebound damping. Gives on-the-fly adjustability, so riders with this they can dial in the level of responsiveness as they desire using this pretty fancy-looking textured knob on top of the 2.0. And I know at Specialized we can really be a bear for details, and I don't want this little knob to go unnoticed. Could you take us through some of the many considerations we took in scrutinizing these details, even down to what seems like maybe an arbitrary little knob on top of the stem?
Yeah, well, I guess first I want to correct you. This is not a lockout. So we just got to make sure that we don't call this a lockout, because it's not. We don't completely lock out the FutureShock with this. What it is an open and close position of the damper port. And so it's either completely open, which we have full movement, or it closes out the damper and it firms up the setting. So this was really born, at the very beginnings of when we showed the first Roubaix to our pro teams, in particular Quickstep. We work really closely with them. As you know, Paris-Roubaix is a really important race for those guys at Quickstep. And they wanted some way of making sure they can firm up their FutureShock whenever they came out of the cobbles. So for those of you who have watched Roubaix, you can see that the race is really won or lost is on the pavement when they come out of the cobbles or before they go into the cobbles. They're fighting for position. And so they want to make sure that they feel that the bike is efficient. While we did a lot of efficiency studies, we learned that the FutureShock doesn't actually rob any efficiency or any power from the legs, but it is a mental game. when your livelihood depends on this bike, you want to make sure that you feel confident on the product, and you want to make sure that the bike gives you those sensations that is being efficient. So they wanted some way of firming up the Future Shock. And it took us a long time to get there, right? It's like we showed them the bike in 2016, and we didn't, we saw Peter Sagan raced it in 2018 for the first time. So, and then it took us a whole year of making sure that it was right for consumers or for riders before we brought it out to the line.
Wow. What a process. And you know what, I can totally relate, using this. I've got my Roubaix here behind me, and personally as a rider, I know that it doesn't sap energy, but to your point, when I'm 80 plus miles in on whatever big day I'm on and I'm cracked, you better believe going up one of the last climbs of the day, I firm that thing up. It's totally psychological. I know it. I do. Yeah.
You're completely right. That's how I am. Like 90% of the time, my Future Shock is completely open. But yeah, those last 10 miles of a 100-mile ride, you're just like, I just want to get home and just firm it up.
Yeah. When I'm just daydreaming, just salivating over a carne asada burrito, maybe a liter of cola and a glass bottle, that Future Shock gets firmed.
Yeah. But on the details, I really don't want to steal a lot of the thunder from Tyler, because he was the one who poured his sweat and tears literally into this Future Shock. I mean, he was the one really driving the dial on top of the stem, and he was the one dialing the boot to make sure we had the right texture and that it collapsed exactly how we wanted it. So maybe Tyler can give us some insights as to like what it took to get those last details dialed.
Sure. Yeah. Good morning, afternoon, everybody. Sorry I was having some technical difficulties earlier in the call, but I'm back. Yeah, as John said, like it's a knob on top of your stem, and we're not used to seeing stuff like that. So it was really critical for the team to really get something that was aesthetically pleasing, but also functioned exactly how we wanted it in terms of if you had sweaty hands. I wear a ton of sunscreen, and so my hands get slippery, to be able to grab that knob at any time, turn it firmly. We know that some of our riders are uncomfortable even taking their hands off the bars, for that matter. So just having something that was as easy to use as possible was absolutely critical for us. In terms of challenges with it, that transition between the rubber and the aluminum on the top to get that parting line to have less than 0.1 millimeter gap, that was just a struggle working with our manufacturing partners to dial in tooling, many trips to make sure they were doing exactly what we asked. And then just even the little reliefs on the knob itself were sweated over by our industrial design team, just to make sure that everything was up to our standards. Boot thing. Go ahead, Jared.
Yeah, I mean, I was just gonna, kind of point out and bring light to the fact that, cycling, our little cycling world really is heavily steeped in tradition, and I think sometimes I feel like that can be overlooked, but certainly worth acknowledging the level of tradition that we have, and how that plays a part in you creating these things and sort of driving this innovation. And really, it's a knob, but we are expecting people to accept this when we have such a long history of having some expectations of traditionally what we see and feel when you look down between your handlebars.
Yeah, I mean, going back to what John was talking about in terms of the challenges we faced while developing this system, one was even adding suspension to the Roubaix, which is a very classic platform. To take such a radical step to firmly believe in suspending the rider, convincing the business that this was the right thing to do for the ride and for the product, that was something that ultimately riding the bike that answered that question for everybody.
Yeah, absolutely. Now, Tyler, I know that your time is short. You manage, you oversee a host of engineers, and you and your team are constantly scrutinizing details on a wide range of everything that really comes out in the family of bikes for us. And so while I have you on the line here, I was really hoping that you could shed a little light on what's happening internally on this Future Shock 2.0. We talked about it having hydraulic compression and rebound damping, but it's not exactly that simple, and I'm sure there were a lot of challenges along the way in bringing this to fruition. So could you speak to us about what we're looking at here?
I think just from a BOM standpoint, we added over 50 parts to the Future Shock. And so that's a lot of stuff to cram into that tiny space. What we're looking at is a through shaft damper. That was something that was chosen to really mimic the behavior of Future Shock 1.5 that does not have damping. I think it's really critical to point out that one of the targets is in the open position. Future Shock 2.0 is essentially Future Shock 1.5. We did not want to add any additional damping in terms of compression or rebound because we really believe in the ride that the original Future Shock 1.0 and that 1.5 provides. But speaking to wanting to adjust on the fly, hydraulic damping is the best way to do that. And so this is a 2-circuit system, open position. We have a free bleed that essentially does not provide any compression or rebound damping. It's very immeasurable when we put that on the shock dyno. But then when you close off the free bleed, that's where the magic happens. We run it through a traditional piston with both compression and rebound shim stacks, but it also has our spike valve technology in there that's in some of our suspension forks and rear shocks. What that does is it allows us to control both high speed and low speed compression damping to really give the rider the best experience across all, whether it's a fast, big pothole or whether you're just kind of going over chip seal roads to give you that firmer feeling that some riders were asking for.
I understand. And so this, going into this world and using the spike valve that we have on some of our other mountain bike technology, I imagine you were spending a good deal of time in the suspension lab and involving that team as well in the development of this.
Oh, absolutely. Some of you on the call may know Mike McAndrews, better known as Mick internally, who's just a suspension guru. He's been with Specialized for quite some time, and before that with some other big brands in the suspension universe. But I was down in the suspension lab with him daily, up to our elbows in oil, trying to get this thing dialed.
That's incredible. And, at least personally, kind of from the outside, it seems the suspension lab is generally, to me, would be a very unlikely source of improvement or involvement with developing a road product. But
a funny story.
Yeah.
So Mick McAndrews was actually involved in the RockShox forks that were used at the 1994 Paris-Roubaix, which won Paris-Roubaix back then on a mountain bike or modified suspension fork. So when we started the project, we kind of teased Mick that, hey, we're going to get you another Paris-Roubaix win.
And we certainly did do that, didn't we?
Twice.
Bravo. That's a great story. I mean, to me, it just speaks volumes about our innovation internally and how so many different teams have had to come together to really bring this thing to life. Whether it's our in-house machine shop, carbon facility, suspension innovation laboratory, and working with with product teams and engineering teams and everybody coming together. As a little old rider myself, personally, I find that incredibly inspiring. So thanks, Tyler, for giving us a little insight into what's really happening inside this little hydraulic cartridge and sort of demystifying this thing for us.
Jared, you're absolutely welcome. Thanks for having me on.
You bet. And speaking of demystifying, as well as speaking to the addition of something included in the front of our bike that maybe some of us we're just not used to. Having this cartridge in here, John, this does impact the way that we talk about stack and reach on the bike. And I understand this has been, something that we have heard a bit about. And it's worth talking that when you look at a geometry chart for a future shock equipped bike, it may tell you the head tube height. But the head tube height on this is not what we're used to seeing when you try to measure stack and reach. So head tube height being the actual height of the head tube on a future shock bike isn't necessarily relevant if you're looking for stack and reach. So this is we would like this to help illustrate what you're really working with, and that the point of measurement would be this red line underneath the stem where the stem interfaces with the top of the future shock cartridge. Is that put effectively? Do you have something to add, John?
Beautiful, Jared. Yes. One of the biggest questions that we get is, especially from bike fitters, is, hey, the stack and reach numbers, they don't match the frame. And us, like you mentioned earlier, cyclists are really ingrained into tradition. And so traditionally, we have measured stack and reach to the top of the head tube. Well, for a future shock bike, we need to measure stack and reach to actually the bottom of the stem when using the 0 mil or the lowest possible headset cover. So on a Roubaix or Diverge, that's going to be the 0 millimeter headset cover. On a Creo or a Vado, it's going to be with the only headset cover that it comes with. That's how you would measure stack and reach.
Okay. Crystal clear. And, on this, as we were talking about 2.0, now we're talking general future shock. I got a question here from Jim. What will be the expected regular maintenance of future shock 2.0?
So the regular maintenance of future shock 2.0 and 1.5, they're no different. They still have the 500 hours that we suggest for the future shock to get serviced at. The damper is completely enclosed. The only thing that when we service a future shock is those roller bearings and the shims that are inside that maybe over the 500 hours, they lose a little bit of the grease viscosity, and they become a little bit rougher. But other than that, there's no difference in servicing 1.5 to 2.0.
Got it. Okay. Brilliant. No, that's it. That's what we've got on the Q&A board for now. Thank you for settling that up. And with that, what are we looking to take away from our future shock summary? Whether it's 1.5 or 2.0, you can expect 20 millimeters smooth axial compliance. Suspends the rider while maintaining efficiency. The 1.5 is fitted with progressive wound spring. The 2.0 has hydraulic damping, which gives you on-the-fly rider adjustability. It was born from Roubaix, but at home across many platforms. You have any closing words or anything else you'd like to add, Mr. John?
No, I think you covered everything. Thanks a lot for having me.
Absolutely. Yeah, thank you. Thanks for joining. And I'm sure I'll find something else for you. Looks like we've got Got another question here, a geometry question. But why do you measure the stack where you do?
Because that's the lowest point of the stem. So that's the lowest the handlebars can go, regardless that's the lowest point. Whereas on a bike without a future shock, you can essentially remove the headset cover and you can get the stem lower to get closer to the top of the frame.
Right.
Which a lot of people do.
Absolutely. You know, in my earlier road racer days, I was one of those guys. I know it very well. Nowadays, not so much. But in short, Jeffrey, who's asking that question, it's that point on a future shock bike is the most effective way that we can mimic that point to where we would on a traditional bike. With the future shock in the lowest position, that's as low as that stem is going to go. If you have any further questions on it, Jeffrey, I'd say email me or John. I'm not sure how I don't think we can make it too much more clear than that. But that being said, we are coming up on time, so I think we can wrap it up. I'm sure you've got a whole lot going on. John, we're launching a new product. We've got all sorts of things with Future Shock on it, and you're a busy boy.
Yeah, I'm going to go ride, test some product.
There you go. All right, well, I appreciate you being on.
All right, thank you.
Enjoy.
See ya.